Also, I don't think like we've actually ever introduced the two of us, from our previous session, since that was our first session. So I'm gonna just introduce myself. I am Sirisha. I am one of the Pittsburgh Jug leaders. I work at an investment bank in Pittsburgh, and then we've been doing a bunch of these sessions, and we want to do this more frequently, almost like every. It's going to be monthly sessions, and we want to do this like every second Thursday of each month, and that's what we are aiming to do. And most of our registrations will be available at Pittsburgh Java Meetup registration, or you can follow us on Twitter, and then you can find our information about our, I guess, like our upcoming sessions. I'll hand it off to Renat to introduce himself, and if he wants to say a thing or two about Pittsburgh Jug.
Yeah, sure. So my name is Renat. A lot of my information is similar to Sirisha. We're co-workers. We both are Jug leaders for the Pittsburgh Jug. Yeah, we just want to have frequent virtual sessions now that the world is the way it is. We did have an in-person session back in 2020, but hopefully at some point we can return to those. But for now, virtual sessions are great. Not much to add other than, yeah, follow us on Twitter, join our meetup. Both the information's on the slide right now.
Right.
Yeah, that's about it.
So I just want to add just one piece of information. So we have sessions booked out all the way until June. So the next two sessions are on April 8th and May 8th. On April 8th, we have Matthew Gilliard presenting to us on 2FA to Furious. It's a fun topic. It's going to be a 2-hour session. It's going to be a guided workshop. The first 1 hour is going to be a presentation, and the second half of the session is going to be an actual workshop, which you can follow along and code with Matthew. On May 8th, we have Pratik Patel presenting to us on cloud native anti-patterns. And on June 8th, we are going to have Monica Beckwith, but I don't have the topic information, but you just have to keep an eye out on our meetup information, so you'll get notifications of our upcoming sessions.
Well, I'm sure it has to be on garbage collection.
It has to be on, yeah, it's going to be on garbage collections, I guess, but we don't know like exactly what the topic is going to be. So I'm working with her on that. With that, I want to introduce Chandra Guntur. Chandra Guntur is a Java champion. He is also a Jug leader at Garden State and at NYJavaSec. He's a blogger, he's a tweeter, but more importantly, he is I actually, you know what, I should stop here because I know, like, I think Chandra, you'll probably introduce yourself and give a bit about your background as well.
Well, you about covered it. Thank you. It's just that my Twitter handle is @cguntur, and I can be found there. Most of my friends here usually troll me in a friendly way on Twitter. As long as you want to participate in that fun, please feel free to follow me.
Cool.
Right.
You can take it. Yep.
Thank you both, and thank you all for attending. I know it's a Friday, it's a Thursday evening, and we have a parallel amazing session going on at New York JavaSec, where a lot of people are also divert their attention towards. I should have been there as a part of the leadership team, but I'm here presenting. Thank you to Pittsburgh Jug for hosting me here. So I'm going to share my screen and we'll get started in a bit. As I share my screen, as we go through the code, I'm going to request that you bear with me, and I'll be turning off my camera. I get distracted very easily by looking at my own picture. So I'm going to get rid of that when I start showing you code. But let's get started anyway. So here goes, sharing my desktop. Today we'll talk about Java completable futures, and we'll use the example of Paneer Tikka Masala, which is an Indian dish that we cook. The whole concept is we are going to build out the recipe using different features in completable future, and that's what we want to come up with. This yummy looking dish that can be served both with bread and with rice. Of course, you can also serve raw chilies and green onions with that. So yeah, that's the recipe that we're going to look at. The way we are going to lay this out is I'm going to first share with you the actual GitHub URL. It's located at Paneer Tikka Masala under my GitHub link. Sirisha and Renat, if you're kind enough, can you please mention that like anyone asks on chat, and I'd appreciate that. Great. Very quick about me that you've already seen from Sirisha. It's the same thing, so I don't want to bore you. One other thing that I would add is I'm a Satanist, not a Satanist. So please do note that difference. I'm a follower of Carl Sagan, not Satan. So please, do not confuse me as a Satanist. This is my GitHub profile. And one of the GitHub profile repositories that you'll find is Paneer Tikka Masala, which is what we're going to talk about today. The way we will lay this out is basically, I'm going to walk you through some of the Java APIs that are involved. But more importantly, this is the whole recipe of making Paneer Tikka Masala, right? How do you make it? You first check for your ingredients. There are a few ingredients it needs, as of any other dish. You require some quantities of a dish of different ingredients. Then you make a couple of items in there. There are two parts to making Paneer Tikka Masala. There is making the Paneer Tikka, which actually is nothing but cottage cheese marinated with some veggies in unsweetened yogurt. And that's what is called Paneer Tikka. It's just a marinated cottage cheese cubes along with some veggies that we'll talk about. And the second part is to actually make the puree, which is called the masala. And this is nothing but a tomato puree that you create with some other spices and ingredients. And we'll see how completable futures fit into these. And that's the whole intent. I mean, it's the topic itself gets me drooling because I'm a huge fan and I consume this very often. But more importantly, as I was cooking this, that's when the idea struck me that, hey, everything I'm doing depends on something that has to happen later. This could be a prime example of showing how completable futures work. And after we're done with part 2A and 2B below, that's when we actually put everything together and cook the Paneer Tikka Masala. Once we cook it, we can also, do some garnishing and stuff. So this picture is available on GitHub. So you understand and flow along with how this recipe is set up. So very quickly, jumping back to here, you will notice that there are some assets, and in the assets, you'll find the recipe itself. Should you scroll down, the recipe shows up, and when you click on it, it expands to what you're seeing over here. So I'm going to get rid of this now. This is Paneer Tikka Masala, as it looks like, in case you're not familiar with Indian dishes. And there are a few pictures in how it gets made. So I'm going to quickly scroll. These are the ingredients, and we'll cover that as we go along. The site is hebarskitchen.com. And if I've not already included the link, I will be including a link in the GitHub page. So you can actually, in real life, make this. Here we take curd, which is nothing but unsweetened yogurt. We add some spices to it. We mash this up. This is what is the masala being, the paneer tikka's base being made. Then we have cottage cheese cubes. We mix them in and we marinate for about 30 minutes. And then you can either, roast or grill based upon what your choices are. Both work. So basically you do that, you flip over, you do something, you add bell peppers, you add some more spices on it. And then you make the actual masala, which is nothing but starts with a butter base. You add onions, spices to it, and then you add tomato puree and make a base out of it. In the end, you also add some cream, which is probably not mentioned here, which is what is the trick sauce. But yeah, so once you do that, you basically mix the paneer tikka into the masala and you simmer and cook for a few minutes, you garnish, and there you have it. Paneer tikka masala is ready for you. So this is what we're going to do using completable futures. Unfortunately, we're going to not have the aromas that are required for this. We're not going to have the actual dish prepared. We will just have to visualize that for now. In a future session, maybe should fire departments allow, I'll probably bring in a stove and do this in person, and we can get to eat it at the end of the session. But for now, it's all imaginary. Great. So I'm going to stop there, and I'm going to check if there are any questions about the link or the URL, if there are any concerns about what I shared thus far. Otherwise, I'm going to move forward.
You're good, Chandra. I haven't seen any questions, and I've already pasted the link on chat as well.
Appreciate that. Thank you. So here is it's the same site. This is nothing but the Paneer Tikka Masala in a light background. I have a visual defect, so I can't see this. This was more for your benefit. But I've set it up on a dark screen with a larger font, so it's much more visible. Please feel free to start the link, watch this project, whatever you want to do, if you're interested in this project. So a quick summary or overview. I don't want to spend more than 10 minutes on this. What is a completable future? It's a utility that's available in Java since Java 8. It provides a means of task execution, and the task execution can either be asynchronous or synchronous in nature. It depends on how you want to implement it. It provides both the options for you. A completable future actually is something that was created out of two other interfaces. There is a future interface that has been available in Java since Java 5, and there is a completion stage which was also introduced in Java 8 alongside completable future, right? So these are two different interfaces, and we look at why these two matter to create this amazing completable future entity that we will look at. So there are additional documents in this very GitHub repo that you will actually be able to view on your own screens. And this includes some amount of discussion on future, completion stage, and completion future. So let's quickly jump, as if I clicked on them. I have them open in tabs to make it easier for us. What is a future? It was introduced in Java 5. It's a placeholder for the result of a computation task. So basically what you're saying is, I know this will complete or not complete, I don't know, but let me park it so that I can later on check if it's done or not. That's what is called a future. So you have a hope that it will be done in the future. So something may take a longer time than what you're currently using in your execution control flow logic, and therefore you park it in the future, let it work on its own, and later on you knock on future and ask, hey, are you done? And that's what a future does for you. So it's basically a placeholder for the result of a computation task that has not yet finished. So when the task finishes, the future holds the result, and you can later on go and collect this result from the future. There are a few operations on future, very little number of operations. You have what is called a cancel, which means you stop the future's activity from then point on. It's a request to stop. It doesn't actually stop. So make sure that you understand that just by calling a cancel, you have not actually stopped the process. It's an attempt to cancel. So just keep that in mind. There is a get operation. A get operation basically fetches the value of that future. So it's basically a blocking IO kind of a mechanism. So you're blocking until you receive the output of that future. Okay. You may specify a timeout period. And if you specify a timeout period, it blocks until the given time. And after that, it returns as a failure. Right? Should the future have completed before that timeout period, you actually get the value. Otherwise, you get a failure back. Now, you can always check if the future is canceled. Let's assume you invoke a cancel or something in the future's task cancels it, and is cancelled will give you a result of a Boolean value of true or false. And is done is the opposite of is cancelled. It lets us know if the future is completed. Okay, so if the future completes normally without any exception, and is done should return true. So the is methods obviously return Boolean values, and then is cancelled and is done are semantically complementing each other. So that is a future. The next thing I want to look at is completion stage. This is much more elaborate, and the APIs for this are quite out there on Java. So you can also click on these links. They are API links. Same with future. So if you wanted to see what a futures API looks like, you can control click, open it in a new tab, and you'll see the futures API. These are the methods we just covered. There's a get and a get with a timeout. So I don't want to belabor the point on completion stage. You can do the same thing on completion stages yourself. What is a completion stage? This was introduced in Java 8. And it's an interface, again, to represent both an asynchronous or a synchronous computation task. And the task basically performs an action and can invoke another completion stage. So basically, it's a chainable mechanism of futures. Okay, so rather than just what futures do, which is basically take a single task, execute them asynchronously or synchronously, and you can get a result back out of it, a completion stage's main focus is to create stages in a pipeline. Okay, so it doesn't focus so much on a future, it focuses on stages that can be completed after one another or together, or maybe you want to pick one of the multiple stages that are working and say, as long as one completes, we are good. As long as X number complete, we're good, is what a completion stage gives you. So I'm setting up a stage for you, stage being a pun here, of why a future, which is only future based, and why a completion stage, which is like a chaining of different kinds of tasks, can be married to create what is called a completable future. But let's very quickly look at completion stage, right? There are some patterns in method names in completion stage which are important, and these carry forward in completion futures, completable futures. So let's take a quick look. There are methods that use an apply in their method name. Now it could either be the beginning of the method or somewhere within the method signature. Okay, so just be aware, as long as you see the word apply in any case, within a method signature, it uses a function. And why do I know this? If you go to the Java function API, you notice it has a method called apply. And that is the feature parity between a function's apply and a completion stage method name having the word apply in it. If you see the word apply in a completion stage, it has something to do with a function. It's a functional computation on a result. Same with accept. What is accept? Accept is basically a consumer API. Accept simply consumes, it does not transform anything. A function takes a value and converts it into something else. A consumer just accepts a value. Its result is a void. It does not give you back anything. It just accepts a value. So why do I know that it's a consumer? Let's go back and look at Java's consumer API. In Java util function, there is a consumer, and its main method is an accept. There is a default method, however, called and then. So we're going to ignore that for now. This is a single abstract method interface, a SAM interface, which is what lambdas are created from. And the method that you use here is an accept. Similarly, a function is also a SAM, a single abstract method interface. And the method you consume is an apply. Okay, so that is how I know that the accept or the apply methods in a function in a completion stage apply to a function or a consumer. The third is very obvious, and you probably have more commonly used this, where if I see a run somewhere in my method signature for completion stage, I know it is associated with a runnable. Again, jumping back to our APIs, runnable is an interface. It's again a single abstract method interface. It has one method, and the method is run. So this is how you know that these API markers or I guess nomenclature in their method signatures correspond to whatever you are invoking, and you know what kind of operation they perform. A run and a consumer are quite similar in what they do. A run executes, a consumer takes a value and executes. That is the main difference. A consumer relies on the output of the completion stage, while a run does not. And that's the main difference between an accept and a run. This is a common question many people ask. So that is the difference. We'll again look at this in code, but I wanted you to be aware when we get there, you'll have some amount of memory saying, oh, Chandra did mention this. Consumer takes the value of the completion stage. Runnable does not depend on the value of the completion stage. And that's something I want you to sort of park in the back of your minds. Next thing we'll look at is action methods. There are different kinds of method signatures in completion stage. We looked at some verbs, apply, accept, and run. Now we look at some other nouns in there: compose, combine, exceptionally, when complete, and handle. The compose method is basically something that allows you to bundle together various stages. So you're building a pipeline, okay? So one after the other, or one when something fails, etc., is what a compose does. A combine does something slightly different. It flattens it all into one single completable future. So if you have three completable futures and you combine them, you're effectively creating one completable future that has available values of all three. There could be an and or an or kind of operation. We'll look at those later. But a combine is basically flattening it. It is similar to what a by function does, which is it takes the values of two or more. In a by function, it takes two and then combines them into one single output and transforms two values into one. And that's what a combine does for you. So it flattens. And exceptionally is basically a pipe-like handle. And I'll show you that in a minute. This is basically a pipe where you're having a successful operation, and then you pipe into another side pipe whenever you have some problem with one of the stages being executed. And this stage, the pipeline stage, can also do something different. Maybe it puts you back on the success path later, or maybe it continues with the exception path. So it's a routing of the control flow based upon some exception happening is done through an exceptionally kind of method signature. There are several exceptionally method signatures. We'll look at one. Same with when complete. When complete is basically, it can handle either a success or a failure. In case of a failure, you get an exception. In case of a success, you get whatever the value of the completable future generic was. And we'll take a look at it. Just remember that concept. So these are three different ways of handling both success and failure scenarios. Is what I'm trying to explain to you. Exceptionally creates a pipe that separates out and forks to a different path. When complete handles either or. And a handle is simply a direct handling of an exception, halting the next stages. So a handle is the ultimate saying, I want to break off if I get this exception. That's when you do a handle. A when complete is basically determining whether or not you want to handle something if it's an exception. And an exceptionally is just a stream process that allows you to go back and connect to the main success stream. And I'll show you that in a pattern as well in a picture. Maybe I have that in a different page, but I'll get back to that in a minute. Synchronicity-wise, method signatures can tell you immediately whether something is synchronous because they have nothing in the signature that says that, or they have the word async in it, which tells you that it's an async operation. Quite simple. If you don't see the word async, that means it's a synchronous operation. If you see the word async, that means it's an asynchronous operation. Should be quite simple to understand. And post-execution, you can perform some activities. So you can either call methods that have the word then in them, okay? The then basically represents there is another stage that comes in after your current stage is completed in that pipeline. A both basically takes in values of two stages, puts them together and does some activity. It's almost like a by function. And then either that again takes two completion stages and performs an action if either one of them completes. And we'll take a look at all these. I just wanted you to know upfront that these are methods that exist. Don't worry too much if you don't understand these right now. When we go into the code, you'll see them in much more detail. You'll get what I'm saying at that point when you refer back to this documentation. Now, last I want to talk to you about completable futures themselves. They were introduced in Java 8 alongside completion stage. It's a complete implementation of both future and completion stage. So any method that exists in future, any method that exists in completion stage, and then some is what completable future is. It provides static methods that execute tasks, and it allows for chaining because it extends from or implements completion stage, and it performs activities on future tasks because it implements future. So it's a combination of both completion stage, which is a pipeline, and a future, which can happen in the future. Classifications are similar. We've already seen the run kind of signatures before. A run signature is basically that performs a task without any return value. It just executes some code. So there is no consumption of anything. There is no return of anything in a runnable. A supply kind of method, we'll take a look at these, which basically perform a task and return something for sure. A consumer only consumes, does not return anything. A supplier does not consume anything, but returns something. That is the difference between a consumer and a supplier. Synchronicity wise, it's almost the same as completion stages. If you don't see the word async, it is synchronous. If you see the word async, it is asynchronous. By default, asynchronicity is provided using the fork join pool, and we'll take a look at it. Just remember, when I go back into code, I mentioned this here, and this is where you look up for later reference. The default is fork join pool, and you can override it by creating your own executors. There are special cases where you need an executor, other cases where you should simply rely on the fork join pool. I would much rather rely on the fork join pool if it were up to me, but I'll show you cases where using an executor helps. Result-wise, there are two methods now that completable futures use. So I don't know if you remember, but future had a get operation. We talked about this. And then there is also another option called join in completable futures. So a get operation is what a completable future inherits from future, but it throws checked exceptions. So you will have to put them in a try-catch block if there is a failure or if this completable future is not successful. And then there is a join operation, which is very similar to get. Both of these do exactly the same thing in terms of purpose, but the join operation throws unchecked runtime exceptions. So you no longer need a try-catch block to get something. Now the failure can result in a runtime exception, which has to be handled elsewhere, but you're sort of throwing the problem elsewhere rather than you having to deal with it in a try-catch block. Both are useful. We'll see examples of both. Now, as far as chaining and combining, we've looked at compose and combine before in the completion stage. The then compose, which is a complex verb that contains both then and compose with a star in it, basically ensures that a second stage, there are two completable futures, where the second completable future is executed after the first one as a result. Okay, and therefore it uses the first one's output as a function input. So it takes the first one's result into a function and invokes a second completable future. It's a chaining process where I have the value of the first being used in the second completable future. A then combine chains two completable futures, and when both are simultaneously completed, it uses the result of both in a by function to give us a value. So you see the difference. One is chaining serially and the other is chaining parallelly. That's what it looks like, right? So that's what a compose and a combine do for us. When you want to combine all, like multiples, then you can do what is called a then except both. So this is where both are completed and you use the results of both into a consumer because it's an accept kind of method. You'll see a pattern there. And then you have what is known as run after both. Since it's a run kind of operation, you know that it will execute something after both completable futures complete. So the operations are quite simple to understand once you understand the nomenclature and how they came up with these names. There is something called all of. This is probably the ultimate of all of the above. All of implies that it waits for the completion of all completable future instances that I have listed. If I have 10 completable futures that I bind together and I call an all of on it, all 10 have to be successfully completed for that completable future that I create to complete. So it's a completable future of many completable futures that have to complete. And then there are either kind of operations, right? Apply to either. So let's assume you have two completable futures. If one of them succeeds, then it basically applies the value to that function and returns a new completable future. Except either basically again does the same thing as before, except as for a consumer-based structure, as you can see, and it consumes any one of the completable futures completion stage, a value, and uses that to create a consumer out of it. Then you can do run after either, which is a run kind of logic. So you'll notice that there is an apply, accept, and run model. We've seen this before, nothing new. It's just standard. And the last most powerful feature that is in the combination strategy is an any of. So if I supply 10 completable futures, it waits for at least one of them to complete. If one completes, then it takes the value and returns a completable future of object. Okay, this is very important. It does not return a completable future of the same generic that you used. It just returns a completable future of a generic object. And that's important because you can morph it into a different object at that point. Right. So the same with all of actually returns a completable feature of void, and that's something you should be aware of. So these are small nuances that we will discover in code, but that is what we are getting towards. Now for a visual of what we just said, right, I'm going to ignore the text here, but here's how a completable future pipeline looks like. A completable future can begin on, let us say, a stage and its output leading to another stage, leading to another output, leading to another stage. Now, if this stage fails, then it causes an exception. And this exception is handled somehow, which may lead to another exception, which may be handled. And maybe this exception handling puts it back on the success path. And then other stages on the completion future can execute. Maybe it doesn't, and it continues on the exception path and results in a failure. Right? So you can have many scenarios where either you're going like this, you're going like this, or you're going like this. The paths are variable, and you can set up these kinds of paths with completable future chains. And that's what we're going to look at in the Paneer Tikka Masala. We'll have recipe parts, and they will all have to succeed. And therefore, we will create a Paneer Tikka Masala dish at the end. Or maybe we'll have some failures, and therefore we will not be able to create our dish. And that's what we're going to look at. Any questions before I move into code? Am I going too fast, too slow?
No, no, you're good. I don't see any questions on the chat, but if anyone's got a question, you can feel free to unmute yourself and ask the question.
Great, thank you.
I was just going to say, I think you're going the right speed, Chandra. Not too fast, not too slow.
Appreciate that. Thank you, Renat. All right, great. So once again, I mean, we've already seen this, but this is my Twitter handle at Guntur. So if you want to follow for some fun activities, that's where I am. All right, so I'm gonna close out of my Firefox, and I'm gonna just leave one open so we can take a look at how Paneer Tikka Masala is set up. So I don't know if you're familiar with Git and checking out from Git. Basically, you can go and either clone from HTTPS or SSH, depends on what you do. I generally use HTTPS because it's easier to set up. It's not safer compared to SSH, so it depends. You copy this, you open a terminal or a command prompt on your screen. Bear with me, I have a screen sharing pop-up that blocks what I see on my screen, so bear with me, okay? So you open up a terminal or a command prompt and you navigate to the directory where, let us say, I go to projects, and under projects, I have conferences, and under conferences is where I can do a Git clone and pass in the URL that I just copied, and lo and behold, I can actually, I'm sorry, I didn't copy it actually. Give me a second, let me just replace this. Let me also increase the font so you can see what I'm doing. Okay, So I do a Git clone and I paste that particular Git link. If I hit enter, it basically checks out the code. I'm not going to check out the code right now because I already have this checked out. So once you check out the code is where I will proceed. If you don't have the code, you saw the steps on how to check it out. So what I do generally is I go to IntelliJ, and from IntelliJ, I basically go open my project structure. I go to my projects. I go to the conf, which is where I'm located. I know my screen is very tiny here, but bear with me. I'll explain and walk you through this. This is where I checked out my code under Paneer Tikka Masala. I should have a pom.xml file. So you can click on the pom.xml file and open it. Right? That's how IntelliJ can set up your project from a POM XML file. If you're using Eclipse, you do an import Maven workspaces, and then you can import it in. If you're using NetBeans, you do the same thing as IntelliJ. You basically open a new project and navigate to the POM XML file, and it sets it up the same way IntelliJ does. So most popular IDEs work. I don't have any idea about how Visual Code works, so please do not ask me questions about that. I myself have problems understanding the layout on Visual Code for now, so bear with me. I don't know the explanation, but if you do, please do share on the chat. So this is the same README you saw on the website, nothing different. It's just an ASCII doc renderer. If you don't see this, don't worry. You need a plugin called ASCII doc plugin. And once you set that up, you see this nice little menu where you can either see the text as you would see it if you don't have the plugin, or you would see a full preview as I do because I have the plugin. Okay, so you should be able to see the same code within your IDE as you see on the browser. So a quick walkthrough of what we have here is basically you check out the project. We already checked it out. We know how to set it up. I've mentioned how you basically set up your project. And then we'll run the main class and it will fail right now because this is what a kata does for you. And then none of the cookie recipe parts will work, and therefore we have to go fix them. And how do you fix these? There are broken and empty sections that have to-dos and hints. And you will have to set those to-dos and hints yourself, fix those to-dos and hints yourself. And then you repeat on every single class until all the recipe parts print correctly. And then you check the solutions to see that you're basically solving it correct, and boom, you're done. You can delete this repository and repeat those steps until you get familiarized with the patterns of completable future. Now, in order to solve, basically, there is an order to solve this. We'll first check for ingredients. We'll make Paneer Tikka masala, then we'll make the masala itself. We'll cook, and then we'll have a chef role which basically orchestrates the whole thing. So these are the how-tos, and this is the chef actually performing the task, right? And so yeah, this was a little bit of a developer joke, but what do you need for this? You need Apache Maven 363. IntelliJ usually bundles 363 with itself, so that if you have IntelliJ, you already have this covered. JDK 11 or above is a better thing to use. Don't use Java 8. This is tested with OpenJDK 15 on my laptop. It also works with 16. I'm just using 15 because it's already released. I use IntelliJ Ultimate. The project structure is like so. There's an IDE file directory that has run configurations in it. There's a POM XML file, which is what rendered our project for us. You're looking at the README file, and there are assets like all the documentation that you saw for future, completion stage, completable future that we saw on the website on GitHub are all listed under assets. So you could actually navigate directly from there. So if you were here, you could actually click on these and these will open pages in IntelliJ for you. Okay, so everything is available on the screen. You don't even have to go to the website once you check out your code. And then you have your source main Java, which is where you have common classes that are used both by the solutions and the kata. So we'll just quickly skim over these. We'll not spend a lot of time. This is not our area of interest. These have been set up as utility classes that we will use in both the kata and the solution. And then you have source kata Java, which is where all your broken code is, which is what needs to be fixed. And then you have your solution package, which is where all your solutions, the working recipe exists. So in case you fall somewhere, you know you can always refer to the solutions and go fix your code based on that. Okay. Once again, I have a mapping between the kata and the solution. So if you're on this is the solution for that, and so on and so forth. You can click all these in your IDE. So you can simply go click on solutions and it opens that up for you. So that's readily available. You don't have to do much. The key takeaway is that you understand Completable Future API using some fun cooking recipe, and that's what we're going to do. With that, I'm going to stop sharing my screen, sharing my video, and I'm going to start focusing on the coding part of it. Any questions before I begin, or as I'm setting it up?
There is one question on the chat, Chandra.
Go ahead.
So the question is it possible to get completion stage value and exception thrown at the same time on dot handle?
Not on handle. There is a when complete method that does that for you, right? So when complete allows you to either get a valid value as a result or an exception, should there be an exception. So
Okay.
handle is the wrong method for that. I would much rather use a when complete for that.
Okay.
Good. So a few housekeeping items that most of you will probably need, right? So what I do is in my preferences, I have my, I guess the first thing I would like to share is that my color scheme is set to presentation mode. So it should be big enough a font for you to read. So that's something I usually get asked. And the next thing that I get asked is how are my screen to-do colors showing, right? So I have my to-dos in my editor. So if you go to editor to do, you will notice that there are patterns that I create. So to do, for example, if I were to edit this, I've set it to a color of this particular color, right? And I created a new to do of type hint, and I set it to a color of cyan. So that's how you'll notice that my colors show up differently, and I can use these visual cues as I go along. If you don't have them, don't worry. You just have to set them up the way I did, and you will be all set. So if you go to type in to do under IntelliJ preferences, you go into an editor to do mode and you can set up the colors as you wish. So that's what I did. And that's why you'll see different colors on my screen. What's our agenda for today? Our agenda is basically to make Paneer Tikka Masala. First, we check ingredients. Then we find out how to marinate paneer, basically cottage cheese and veggies marinated, how to make tikka masala, and then how to cook these two together. And then there's actually the final, make it all, right? Don't just think about the how to. Actually, this is the recipe orchestrator. And that's what we'll do. So let's begin by first looking at part one, check ingredients. I'm going to quickly open up my structure view so you have an idea of what my API looks like. I'm going to ignore the project for now. Bear with me. So if I were to go look, there is exactly one method of importance here, which is check ingredients. There are other methods in there. I'm just not showing them, right? So there are private methods that you don't see. There are many methods. I've actually just hidden them, showing you the only public method that you care about at the end of the day, which is check ingredients. These are the ingredients we look for, right? There are a few ingredients. Fine. Everything looks good. Now, if you look at our first API, this is where I explain what I'm doing, right? Successfully find red chili powder, because one of the ingredients here is probably red chili powder. So we have to look for a successful red chili powder. Then there is a success message. And it says there is a to-do here. And the to-do says create a completable future and replace the null with a completable future. And it says null here. And it gives you a hint on how you can do this. So if I read the hint, I know how to solve a problem. Another way to look at my to-dos is in IntelliJ at least, I have a to-do tool window. And on the to-do tool window, I can go to current file and it shows me all my to-dos here, right? I have set a filter and my filter says only show me the to-dos and not the hints. Okay, and that's what I said. So you only see to-dos here. So basically what we're doing is looking over each to-do and solving it and going along in this equation. So let's go take a look. So the first one says successfully find chili powder. How do I find successful chili powder? It says use the static method completableFuture.completedFuture method with the success message. Sounds simple enough. So I'm going to simply be lazy, copy paste and say return. And I'm going to paste this and it says use the success message. And I use the success message. That looks like it is complete. Now, if I were to run this code by itself, it's not going to produce anything. And how am I telling you that this is working? How am I justified in that? I don't know. So let's do this. Let's quickly run the solutions first, see what our desired outcome is, and then we'll know how to backtrace our way when we complete our code. So I'm just running the solution Paneer Tikka Masala and not the kata Paneer Tikka Masala as you see here. So if I were to run this, hopefully I don't embarrass myself in front of you, and it runs. Okay. So you'll notice a few colors here, a few cool icons that I put in my logs. It starts off by creating Paneer Tikka Masala. It does a check for ingredients. And one of the ingredients you'll find is red chili powder. We found it. And then we basically go into timer stages. Anywhere you see a red icon, it basically implies that there is a timer of some sort. I'm sorry, whenever you see a white, you know there's a timer of some sort involved. So you'll notice a time icon or a clock icon next to it. It'll have a white text and then the actual action that we are performing. So you're basically here chopping paneer for 5 minutes, and you'll notice that the equivalent here should be about 5 milliseconds. So we have a mapping between the milliseconds and the minutes, and that's how we know things are taking the time they are. And I'll show you the code on how we did this. So those are your different aspects of the cooking. There is a check ingredients, there is a creation of paneer tikka, there's a creation of masala, and then there is the actual cooking process after you marinate. And then this is the final, you completed your paneer tikka masala in about 1 hour, 45 minutes, which is what it usually takes to create this dish. Now, I know it's a lot of investment of time to do that, and we're not going to take the hour 45 minutes for our code kata, but I just wanted you to know that is what it is. Now, looking at the code itself in the main method, under Java, I have exceptions. We'll use these exceptions. These are the recipe parts, I guess, main class or the parent class of all the recipe parts. I have some methods here that allow me to delay. So what I do is I convert a delay of X number of minutes by mapping it into milliseconds. So we're not wasting all the 1 hour 45 minutes doing this demo. We basically map it into the number of milliseconds in a minute, and I map it by 1,000. So each 10 milliseconds represents a minute, and that's how we've set it up. Under utilities, I have a thread factory we'll take a look at. This is useful when we go into executors. And then there is a timer utility that I don't use, but it's set up so if you wanted to actually time this and see how long it takes. So we can ignore that part. Ignore the timer. We will use the thread factory. Okay, good. So that was the main. I don't want to waste too much time on that. This is the solution, and this is the solution paneer tikka masala that we just ran a few minutes ago. All right, back to the kata. So the first one is complete. We did a check ingredients, and we're going to mark this to do as complete by just putting a space between that. It de-highlights it as soon as the word to do is no longer found. The next to do says unsuccessfully find paprika powder. Okay, how do we unsuccessfully find something? It is a failure. It says there is a failed future, and the hint says use a failed future. So let's go use the failed future, and it says create a new paprika not found exception as a part of failure. Okay, so let's do that. So I'm going to do completed future dot failed future, and in my failed future I'm going to create a new paprika not found exception, and the exception message is what I have declared above, which is what I'm going to select here. Okay, so I created a paprika not found exception, and I created a failed future. So I created a success and a failure. Now you notice how completed futures can either be completed or can fail. And that is what you are basically showing with these two kata examples. Now the next method basically says check for paprika and chili powder. We just created those two methods above, successful chili and unsuccessful find of paprika powder. So let's go see what this method does. It says, hey, call the successful find chili powder method. We just fixed this method. And the to-do says, check if the check chili powder is done and has a value. How do we do this? There is an instance method called is done on completable futures, and that's how you know if the method is done. So let's use that method. Check for chili powder dot is done. And we get back a result saying, yes, this is either true or false. Now, there is a get operation that waits for the completable future to complete and then returns its result. So how do we get a result to print out? In our run method, we actually saw half a tablespoon of red chili powder right about here. How did this get printed out? This got printed out because this value needed to be changed. So how do I change this value? Is instead of this empty string here, I have to return the completable futures output. So check for chili powder dot gets me the actual value, and the actual value that I return is red chili powder. And we saw this before, we set this up. So that's how I'm printing red chili powder here due to these curly braces, and I'm formatting that with the red chili powder that I passed through the completable futures get, and I have a half teaspoon of this. Now, another thing it tells me is to also replace the throwable, which is never a good idea to catch, never catch throwables, with the appropriate exceptions thrown by get. So what does the get method throw? So the easiest way to do this is I basically delete the try catch blocks, and then your IDE should complain that these methods throw exceptions and you should handle them. So if I were to use the IDE's features, if they surround with the try catch block and I surround it and I see I get an interrupted exception and an execution exception, both of which do an e.print stack trace. Now, in real life, in production projects, never use e.print stack trace, but we are in a code kata, so I really don't care. But what I see is their outcomes are almost similarly handled. So So why not just combine them? And my IDE allows me to combine them by collapsing the catch blocks, and that's what I do. And this is my final output for checking if the chili powder is done and getting its value. So two methods we've looked at is completable futures have an is done method, and you can get the value if they are done. So we did that. Also, what we saw is there is a completable future called paprika powder that failed, and it was an unsuccessful find paprika powder. How do we handle this? It says handle the exception from check for paprika powder and add a warn level debug message with the exceptions message itself. We created an exception above called paprika not found exception, and it had paprika powder not found as an exception. So how do we print this out here? So here onwards, what I'll do is rather than you seeing me type too much, I'm just going to use the live templates that I've already created, and we will use those instead. So in this case, I have a live template set up for when complete, and let me just run that. What did I do? I do a check for paprika powder, and when it's complete, I can either handle a success message or an exception. And in case of an exception, I can do a logger.1 on the exceptions message. So that's what we've done. A when complete gives me the opportunity to handle either a success or a failure. I don't know if this answered the question that was asked earlier, but there is a when complete method which can handle both. And that's what we used in this case. So one of the things we identified was when you have a completable future that can either succeed or fail, using a when complete is a good option to, I guess, handle both situations. Great. There's a method here that says get pots and pans ready. That sounds interesting. It says dishwasher is running. Maybe it's useful later. It says things to do while we're out for grocery shopping for garam masala. So we'll take a look at that later. Here's our go to store to get garam masala. So obviously we need to go to a store for something because maybe we're missing an ingredient. It looks like we're missing garam masala. Now, for those of you who don't know, garam masala is basically a spice, a combined of 9 different spices in itself, and it's a vital ingredient in a lot of Indian cooking. So this is very important. So we do have to go to the store and get this. Now, what we do is there is a 30-minute duration for us to go to the store. While we are at the store, we want the dishwasher to running, which is what we saw as get pots and pans ready above. So we need to keep this running. And we want to use a run async. And in case you remember, when we talked about this, a run async basically is something that invokes the runnable, but does not take in any inputs and does not provide any outputs. So it's just an executor of sorts, which is executing on an asynchronous thread. So we'll do this. Okay, so here we are. We created a thread context to actually print this out saying, oh, no garam masala going to the store. We create a new timer for the garam masala shopping. And then we give it a delay reason saying we need a store trip. And we're asked to basically create a to-do that takes a completable future and runs an async set of statements to delay for 30 minutes while a store trip is made. Replace the completable future below with the one that logs the delay for 30 minutes for a store trip for garam masala, which is what is the delay reason. So let's see how we can change this. I don't want to, again, type all this text. I already cheated and created live templates, but your interest is not to see me type and make mistakes. Your interest is to understand what I'm doing here. And the hints provide you values there, right? It says, use the static method called run async. Add a thread context for petty logging. We've seen how that we do that before. And basically, it also gives you an example of what to do and says use a delay minutes. I don't know if you remember, but recipe parts had a delay minutes that we used. We saw this earlier, a delay minutes of 30 minutes with a delay reason. And that's what we'll use here. So let's go fix this code. So I'm going to delete all this and say CI, and I'm going to call the run async method. And here's how we do this. So we are doing a get garam masala from store. We're calling a completable future run async method. That's what we were asked to run. It's a static method. And in that, we created an executable. It's a runnable. So I have a runnable lambda that basically calls the run method to first put something on the thread context and delay for 30 minutes using a delay reason. And what does this delay for delay minutes do? Let's take a quick look again. It puts something on the thread context, and it basically says waiting for whatever number of minutes, and then it does a millisecond mapping. So 30 minutes will translate to about 3 milliseconds. After 3 milliseconds, it'll print it as done. And that's what we did over here. So we basically did that. We basically created a store trip that has 30 minutes, but on the screen, it'll appear as 3 milliseconds. Great. So we got that. And another thing it says is while the completable future is not done, other activities can be performed because we know that, it's on a separate thread. So how do I do this is while get garam masala from store is done, there's a not before that. basically what we're saying is, while the store trip is happening, run the dishwasher. So let's go ahead and uncomment this code. And that's how we're running the dishwasher while we've not completed our store trip. So it's going to execute, check again, going to execute, and so on and so forth, right? And the timer ends once we return from the store, because the while will evaluate to true, and therefore the not of it will evaluate to false, and therefore to break the loop, my timer ends. And then I tell you that I returned from the store in the duration from the timer, which reconverts it into minutes, and I know how much time I spent in the store. So now that I'm done with the garam masala, I put the thread context back and I return saying I am done. So my get garam masala is returned. Now, if I'm successful, I return true. Otherwise, I'm returning a false. So if I'm false, that means that my get garam masala is not done, which means I can never move forward. I can never cook paneer tikka masala. So I'm just letting you know. And here is the main method. This is the method we first saw. There is nothing to do here. So let's go fix all the to-dos real quick and make sure that we finished everything that we were supposed to do. So we had all the to-dos that we took care of, and we want to make sure that they don't pop up as highlighted to-dos when we solve this kata. So great, all our to-dos are gone. So if I were to go back to my to-do for the current file, I notice that there is nothing left. And that's how I know I've completed my tasks. I'm not going to repeat this for every single exercise. I just want you to know what we do and how we solve this in real life. Okay, for the remaining ones, I'm not going to mark the to-dos as completed because I know what I'm doing. But should you want to always be consistent with finishing all the to-dos, you should always check this particular box, find out how many to-dos you're left with. Any questions on what we did with completable futures to begin with? We have a completed future. We have a failed future. We investigate if a future is done using an is-done method. A get allows us to get the value, but I have to catch checked exceptions. I can handle exception or success using a when complete. And I can also do a run async operation to run an asynchronous thread that allows me to perform an action in parallel while I still execute on the main thread some other actions. And that's all we covered in the first kata example. Any questions?
You're looking good, Chandra.
Okay, good.
Good, yep.
Awesome. So let's jump on to the next one. And just FYI, folks, we may run a little bit later beyond 7:30 p.m. I hope Eastern time. So I hope you don't mind. And if you do have to jump off at 7:30 p.m. Eastern, feel free to always ask me questions later. I'm happy to answer those. Great. So the instructions of the paneer tikka itself are basically to cut the paneer into small cubes, add the chopped ginger and garlic, add the coriander powder, which is nothing but cilantro seed powder, a garam masala, we've already talked about this. This is the most important ingredient in a lot of Indian cooking. Paprika or red chili powder. We don't have paprika, so we're going to ignore that. Salt and red chili powder. We mix in the unsweetened yogurt, mix everything together, and we basically marinate this in a refrigerator for about 30 minutes. Okay, and that's what we're going to do in this code kata as well. The order of the methods may not match what our instructions are, and there is a method to this madness. So once again, let's quickly take a look at our code structure. You notice that there are two public methods that we care about. Prepare paneer tikka masala and marinate the mixed tikkas. And they're done separately for a justified reason, and we'll take a look at that reason later on. Okay, so I'm going to close my structure view again. And in case any of you are wondering, the structure view only shows you two because I've hidden the private methods. And there are several private methods in there that we will go through as we go along. Great. So going back to the code and getting rid of my structure view, part 2, make paneer tikka, extends recipe part, so I get the delay minutes. We've already seen the delay minutes before. Now, first, what am I doing? I'm creating a completable future of type string, and it's called chop paneer. Paneer is nothing but cottage cheese cubes. You can substitute it with tofu if you don't have cottage cheese. And I'm using something called a prior status. That's interesting. We'll take a look at this. This method is not being used anywhere for now. So there must be some to do somewhere that uses this method. What do I do in this? I use a supply async. That is interesting. We've not seen this before. What is a supply async method? A supply async is like a run async, except it returns something to you. And what is it returning? It is returning a string back to me as a completable future, which is what our return type is. And that's how it's a supply rather than a run async. That's one key difference I want you to observe. Everything else remains the same. I have a thread context. I'm logging something, and I'm calling a delay minutes for 5 minutes while I'm chopping paneer. And once I'm done, I return a chopped paneer as a status. Simple. Then I'm chopping ginger, exactly the same code, not going to repeat it. Chopping garlic, exactly the same code, not going to repeat it. The time is different. Paneer took 5 minutes, ginger and garlic took 3 minutes each. I'm a super chef, I guess. I don't know. Anyways, all this is an interesting method. It says chop stuff. So what am I doing here? It says create a chopping starter, chop all the main ingredients for paneer tikka, and then once you're done, there is a chopping complete string that is set up for you. What does my to-do tell me? It says compose all chopping in a chained sequence and then log the success. Use either lambdas or method references since each method takes a prior status string. Each of these methods has a prior status, which is interesting to know. So let's see how this behaves. All right, chain 3 instance methods of then compose. We talked about compose. A compose is basically a chain where the second completion stage receives the output of the first and uses it in a function and so on and so forth. So that is what is basically using the previous completion futures result, and that's why the prior status. Once all chopping is done, call the instance method then apply. Apply basically does what? It basically takes a value and calls a function on it. So very similar on the successful completion of all the chopping. And then the return of the then apply should be a chopping complete string itself. So an apply method should return something. It takes a function, which means it converts value X into value Y, right? So my return is a string completable future. Currently, it returns a chopping starter, which is empty. We don't do much with that. So let's go replace this. And how do I replace this? So I'm going to once again use the live template magic. By the way, live template magic is not something IntelliJ provides. I created the live template so I can code faster. I'll show you that if time permits at the end of this. So what am I doing? I'm using Paneer Tikka. So I'm going to use my PT shortcuts. And then give me a second. And I'm going to do a chop all method. So I'm basically doing a chopping starter. And this is my chopping starter, which I first created. And then I called it then compose as they basically suggested I do. And each then compose gets the value of the prior and passes it to the next method. So if I get a value of chopping starter returning me a chopping main ingredients for paneer tikka, that's what I pass to chop paneer, and that's what gets printed out as prior status. Its final status is chopped paneer, that's what gets printed to chop ginger, etc. So I'm not going to belabor you with telling you all this individual method outputs, but there is something to note here. This is a lambda. And since I take S and I use S in that method, I can very well replace this with a method reference like so. And this is much cleaner code and it's much more readable when you see code like this. So I can always convert the code into using method references. I prefer this style, but should you have questions about this, I'll answer towards the end of the session. It's basically you can either use lambdas or method references, both work here. I would prefer to use method references. And then there is a mixed stuff method. I'm not doing anything here, no to-dos required. Basically, it says run async. We've seen run async before. I have a mixing bowl. I add the cottage cheese cubes, ginger pieces, garlic chunks. I add coriander, which is cilantro seed, the garam masala. We talked about this, 9 spices, salt and red chili powder. Notice we're not using paprika anymore. Added the yogurt, which is unsweetened. Please don't use sweetened yogurt. That'll ruin the taste. And then we delay for about 5 minutes. So basically, mixing takes us 5 minutes. So it should print something like, mixing tikka ingredients, and there should be a 5-minute delay doing this, which will translate into a few milliseconds in logs. Great. The next thing it says, prepare paneer tikka. And what do I do here? I'm first logging that I'm making paneer tikka, and it says use a then compose to trigger a mix after everything is chopped. So I'm chopping and then I'm mixing. I've thus far not chopped anything because all I said was there is a method called chop stuff. It has not been terminated yet. So I just created a recipe for chopping here. I've not yet chopped anything, right? It is just a recipe. I've never called a join. I've never called a get. So nothing has happened here yet, right? So here is the method. I'm going back to prepare tikka, paneer tikka, where I say use a then compose to trigger a mix after everything is chopped. So I have to first call a chop. And then after everything is chopped, take its value and then compose another completable future that will mix everything together, which is what is the mix stuff method. So we have the methods. Let's put in the body for what we need. It says chopping and mixing completable future. So let's go replace it with my magic live templates. And here is my live template for this, chop and mix. I'm sorry, use the wrong one. usually end up making this mistake, so bear with me. These methods are basically quite confusing because I don't use them very often. I type my code. But here it is. What did I do? I have a chopping and mixing completable future. I first chop the stuff. And once I chop the stuff, I do a then compose, which means it has to complete for the compose operation to take its value, its string output, and pass it in as chopping status to a different method that can return a string. A then compose will actually compose it into another function. We saw this before. So what do I do here? I take the chopping status and I create a new supply async which returns a value provider, a supplier, and I call the mix stuff by passing in the chopping status. If you notice mix status, it takes a chopping status and it prints it out, and then at the end it returns another string. It does not return a completable future, it only returns a string, which means I can only supply async a string, not a completable future. But since I have a then compose, it takes the string value and converts it into a completable future, which is what my output looks like. So there are different ways in which you can handle where something else is giving you the value, you convert it into a completable future, and you return it as an output. So this is how you're chaining completable futures using a then, which also creates another completable future, and compose, which depends on the previous one's result. That's what we learned from this exercise. So it's not enough if you can do this. You've not called anything. These are not terminal operations. Your terminal operations are which actually start the blocking. And that's what we do by calling a join method on this particular completable future here. I can either use the code completion logic or I can simply type this out because it's quite trivial. Is basically I have to call the chopping and I call a dot join method. The difference here is I'm calling a join. In the previous example, we used a get. Get required a try-catch block because it has checked exceptions. Join does not require a try-catch block because it throws a runtime exception. So if we look at code, you notice that there are no throws blocks here. It throws a cancellation exception and a completion exception, both of which are runtime exceptions. So if I were to navigate here, it's an illegal state, which I further look at, it's a runtime exception. Same with the other one, which is a completion exception, which is a runtime exception. So we have runtime exceptions which don't need to be caught during our compilation phase. And that's what we did over here. Right? So a join is useful when you don't want to try catch, but you're okay with runtime exceptions. The last method we see here is marinate makes it tikkas. We probably don't use it in this class. We probably use it, the chef probably uses it towards the end. So we're going to ignore this for now. I'm going to take a quick water break. Anyone has any questions?
Nope, Chandra, you're good. There is one request for live templates and I think code style settings as well. But that's towards the end, if time permits, that is.
Yeah, and definitely will share that. I understand because a lot of people feel very happy seeing those in action. So let me just first mark this as done because this is also another thing that I will get asked at the end. So I'm going to mark this as done. We did the check ingredients. We also did the marinate paneer. So I'm going to mark that as done. So we're left with tikka masala, how to cook and make it all. Okay. So let's go make the masala next. Few steps here. There are like 9 steps. Oh my goodness. Heat butter, oil in a pan, add cinnamon, cumin. Once the cumin seeds start to crackle, add chopped onions, crushed garlic pods, and chopped ginger. So there's more chopping going on here. We fry the onions till they're golden brown. When they're done, we add the tomatoes in the mix. We create a tomato puree. We add the curry powder in. We also add the salt and sugar in. Cook on a low flame for a few minutes. Therefore, there's a delay minutes here, which means this should be a recipe part somewhere. And then we basically, once it's cooked, we switch off the flame, cool a bit, pour the mixture into a blender and puree it. That's what we do. So it's basically creating a tomato puree with some spices in it and some alia in it, alia being onions, ginger, and garlic. Great. So I have a logger. And in this case, you notice that there is a special executor. This is interesting. Okay, let's go back to the actual output to see what's going on. I have check ingredients, which is running on a main thread. Simple, right? There was a main call somewhere and it called check ingredients and everything looks fine. And then I have a timer which runs on a common pool worker. That is interesting. What is this common pool worker? Let's very quickly take a look at my recipe part to see what this is. So let's go to recipe part. And we notice that here we do a thread.sleep on something and it's being run on a separate thread. somehow magically. I don't know what is going on, but looks like Java or the JVM is creating some special thread and assigning my task to run on it. And that's what is basically printing this out for me. So it's nice to know. Good. On my Paneer Tikka masala, when I made Paneer Tikka, I noticed that every single chopping action is happening on this common pool worker thread, not on the main. What is going on here? So if you go back to this code, right, one thing we missed in all of this is whenever I'm calling a completable future option, all of these methods, they are executing somewhere, not on the main thread. And what Java does by default is Java has what is known as a fork join default pool. And that pool is where you're getting the threads from. And that's what your output tells you, that your thread comes from a common pool. Now I have trimmed the output down, but if you actually get the full output of this, you will see that it is from the fork join pool, right? And that's what Java provides for you out of the box. And you'll see that there are two pools, right? There is a pool that created your choppers, and then there's another pool that basically did the work of compose what we did, right? Mixing, composing, and chopping. They're running on different threads. And that is something interesting for you to know. There are multiple threads involved here, right? The timer threads are working on one of the workers, and the actual work of Paneer Tikka is happening on another worker. Interesting. Now, this was all fine, but for the masala, right? We're going to make the masala, which started before this because there's a marination process. We have not covered that yet. We said that we'll do that later. The chef will probably call it. We saw the method, but we didn't execute the method. Let me confirm what I'm talking about. This marinate makes a tikkas. We saw nothing happening here yet. It'll happen in the orchestrator later. So going back to the run code, I have this code. What is Masala doing? Now notice, instead of common pool worker, it now says recipe part. That is interesting. How is this happening? So in case of my make masala, I use what is called an executor from somewhere. A quick sneak preview of where this is coming from is it is coming from the constructor. So someone calling part 2 make masala is passing it an executor. What should be calling it? The chef is probably calling it. So let's quickly jump over and see what it does. The chef creates check ingredients, make paneer tikka masala, and then calls a make masala with an executor. Interesting. And here is where I find my executor that creates a new fixed thread pool executor of 10 threads and invokes what is called the my thread factory. So I'm creating an executor that's not Java's common pool, and there are very rare and special situations where I get to use this. This is usually used when I want to control my execution mechanisms. This is usually sometimes slower than what common thread pool will ever get me, but there may be special needs when I do it. One of the justifications that I use is basically when I want to log special thread details. And here I have my special details. I use my counters and I create threads with the name recipe part %d. And the %d is something that gets replaced every time a new thread gets created. And you'll notice that on line 29, 30, and 31, I create a new thread and set its name to format using the string.format method on the name format, which I created, recipe part -%d, and the %d is replaced with the thread counter. So I'm creating recipe threads that are not from the common thread pool, but are an allocated thread pool that I own. Right? There are very special cases where this would be of benefit, but I want you to understand the difference. In the first one, I use Java's common thread pool, and the second one, I create an executor instead. Which one is better? It depends. So don't ever think one is better than the other. There are different use cases for both. Right? For common cases, it is usually better to use the common thread pool. Now, what am I doing here? I have a chop onions, I have a chop ginger, and I have a chop garlic. We've seen this method before. There should be no difference. I have a delay minutes that chops onions for 3 minutes, chops ginger for 3 minutes, and chops garlic for 3 minutes. Hey, I also have a chopped tomatoes. How different could it be? Not different. It's still a supply async. It chops tomatoes for 3 minutes. So a total of 4 different choppers. Now, I am a chef and I'm sitting there going, oh, I have to chop all these things again. And then I call my, I guess, junior chefs and say, hey, come on, help me out here. Let's all chop these things together, move things faster. And that's what we'll take a look at an example here. So I'm starting all of these simultaneously, and someone is going to chop them for me while I'm performing one of those choppings. So I'm starting all these 4 together. You already know what I'm doing. We talked about this earlier. There was a then compose and there was a then combine. A combine would start things in parallel. And that's what we'll take a look at here. So when I'm chopping everything, there is this method that returns a completable future string. I first log whatever I'm doing. I create a thread context for it. And I have a chopping starter that basically has this method, which is fine. We've seen this method before. And there is an interim empty message, right? That's interesting. We'll take a look at that. And there is a chopping complete message. We'll have to use these somewhere, I guess, because they're currently unused. It says, use your helpers, the chopping helpers, people who are helping me chop things, to chop things at the same time. And use a future that will run irrespective of success or failure. So please bear with me for 1 minute while I take a sip of water. If there are any questions, now would be a good time to pose them. All right, looks like there are no questions. I can see the screen on the chat, so I'm relying on Renat and Sirisha to help me out here. I assume there are no questions.
There is one question that just came in now. It says it may be a very basic question, but how does the thread context.put works?
Okay, so that is not a basic question, and please feel free to ask any questions. It's all welcome. We just have a time constraint. I'm happy to answer everything. A thread context is not related to your completable futures. A thread context is related to logging. Okay, so if you are familiar with logging, you can also seed what is known as a nested diagnostic context, which is ancient, which was replaced with a mapped diagnostic context more recently. And now the latest is called a thread context. This is a log4j, it's a logging standard now that replaces M as a mapped diagnostic context. Thread context does the same thing for that. So it's basically seeding my log messages with a name value pair. There's a map, and that map diagnostic context has this set in there. So when I print log statements, it basically prints the recipe part that I'm using. In my case, I'm using the recipe part value as masala. In the prior example, I was using the recipe part as paneer tikka. And where do you see this? You see them in the outputs here. You notice the masala, you notice the paneer tikka. This is what I'm setting in the logger. I'll show you the log4j XML file later. I use log4j too, but that's how I'm setting those up. Okay, good. That was a good question. Hopefully I gave you a decent enough answer for us to proceed for now. Okay, so what are we doing here? I have an interim message. It says chain 3 instance methods using the then combines on the chopping starter with executors. We now have an executor. Return an empty string for the by function each time. Return the declared interim empty message for each of these stages. Chain an instance method handle async at the end, so we know whether we have a success or failure. Right, so this answers the other question someone else asked before, does handle work? And we'll show you an example here. Okay, so I have all this empty space that I need to replace. So it's a very long method call, obviously, because I'm sort of also formatting my string for readability. But yeah, this is basically chaining a few methods to start at the same time. They are not dependent on one's execution for the next to begin. So if I were to do this, I'm using tikka masala, chop all, let me chop. What did I do? I call the chopping starter. And then call a then combine method, which basically says also start chop onions and take the output of both chopping starter and chop onions into a by function that has the chopping starters output and the chopping onions output, log them, return an interim empty message, which is the empty string, and then combine chopping of garlic along with this outcome to basically chop garlic. And once chopping garlic is complete, return an interim message, use that message and the chopping of ginger to basically start another chopping and so on. So I'm combining the chopping of onions, garlic, ginger, and tomatoes to begin at the same time, and they may end at different times, but when everything completes, it handles the async. The handle async method basically is the end all situation. And basically what I do here is I get the status as success and I get the throwable if there is a failure. And I use the chopping complete as the method for success handling. The failure handling would be another consumer here, right? I don't need the failure handling and I use an executor, right? So executor is basically used as my means of executing all this on an asynchronous thread of my own creation. I don't have executors here. I don't have executors here, neither here, neither here. I only have them here. The magic of all this is, since my handle, which is a terminal operation, it defines an executor, all my combinations also use an executor. Going back to code. So let's go back and look at Paneer Tikka. we first chopped paneer. We waited for it to be done. It returned the chopped paneer. Then we started chopping ginger, and then we completed. Then we chopped garlic. And the times will tell you that what I'm telling you is not a lie. Now we come to masala. We see we first started chopping all of them. So we started chopping at 5:31, 5:32, 5:33. Right away we started. And then we mark the stages as done as time goes by at 5:66, which is when the handle async process got completed. So they completed at the same time when the handle async was called. And they are all on different threads. So you notice what I'm telling you, they are performing the actions of 1, 2, 3, 4 being set up, and then 4, 3, 2, 1 executing. Right? And that's what I'm trying to tell you with combinations. Right? So I'm not giving you information that you're not seeing on the screen. Everything is visible. I'm not lying to you. Right? So then it finally returns a status at 5:66 that everything is done. So you notice that everything completes at exactly the same time. Great. So chopping is now complete. And let's go back into the next method that we have. Hopefully everyone is following along, and I'm not confusing you with the recipe as well as completable futures. But if you are confused, please bear with me, ask questions. Here we heat butter and oil. There's no to do, but let's see what it does. It looks very standard. There's a supply async, so it'll return some string at the end because it's a completable future of string. I have a thread context, and I'm logging heating butter and oil. I delay by 5 minutes. So basically, I'm heating butter and oil for 5 minutes. And there's crackle, cumin, and cinnamon. Looks like nothing going on here actionable. It is basically creating another completable future, not spending time on this. Frying onion and ginger. Basically, we said once we have that, we have to fry the alia. Alia being onions, ginger, and garlic. We do that, and it returns a string. It's a single string return. There is no completable future in this case. That's interesting to know. In fact, I call it run async. So I'm not basically supplying any output. I am returning a string myself. I'm just trying to show you the difference between a supply and a run method. In case of a supply method, I can return the supplier, which creates a completable future. In case of a run method, I am not returning the run because it does not have a return value. I'm returning a string on my own. And that's what I'm trying to show you as a highlight difference between supply and run. So then I add tomatoes and curry powder and cook. Once again, no action for us to perform here as developers of this code. And there's a cool and puree method. Once again, it is just there. We know that there's a delay of certain minutes, and we do all that. These are parts of the recipe that we don't need completable futures for. Now, here is the main method that we need to execute. So if we look at the structure again, there is a constructor, obviously, because it needs to be called, an executor needs to be set, and prepare masala is the only method we need to look at. So what do we do here? It says chain the chopping, heating oil, crackling spices, frying the alia and ginger in an asynchronous set of operations, then log the result, finally log a message that all ingredients are cooked. How do we do this? It says use a then compose async, then apply async, then accept async, and then run async. And we're going to take a look at all 4 of these. And it gives you individual hints. It says use the then compose async to heat and crackle on chop onions and garlic and ginger. So at the risk of embarrassing myself, I'm going to type this rather than use the live template to begin with, at least to show you how I come up with what the hints do. I don't want you to think that Chandra is just, playing around with live templates and not actually doing some stuff. So here we go. So I have a chop onions, garlic, and ginger. And on this method, I basically am calling, give me a second, my enter key got hit. So I'm basically calling dot, what is the method? The then compose async. So I'm calling right, let me just do this. I'll take it on the next one. I'm going to show you how to do the coding myself. So I just want to make sure that I complete this part of the code. So give me a second. Let me get rid of this code real quick. And I type in, this is the tikka masala. And on this, I'm doing then compose async. So I create a chop onions, garlic, and ginger. Then I call it dot then compose. I don't know why this was not typing in my IntelliJ, but here it is. I call the then compose to heat butter and oil, and I use an executor. And then I call it then compose again to basically crackle. So those are 2 operations, to heat and crackle. Once I do that, I'm calling it then apply to fry the onions, which takes a function. So I'm creating a function here, which is what it says, then apply async to fry. And then I'm accepting into a consumer. So I'm consuming the values. I'm not returning anything, and I'm logging that particular last outcome. And after I'm done with that, I'm creating a run async, which simply executes but does not have any return value. It does not take in any value to log an output of a success. So I'm just showing you all the methods that are possible on an async mode in completable futures that accept an executor. Now, you can run the same set of operations without using the executor, and the common thread pool will be used. So I just want you to know there are two signatures for then compose async, then apply async, then accept async, and then run async. And let's take a quick look at that so we don't forget about it. Here is the then compose async that simply uses the default executor, and the second operation that takes in an executor and uses that specific executor to perform the function. So there are two method signatures for every single operation, one with an executor, as in the case of the second method here. You see line 2309 has an executor, and the same equivalent of it above does not have an executor. So you can use both. In our case, we use the one with executors to make a point about using executors. Here's how you use a void. Sometimes you get a void back, okay? And it is important to know that void is a special object when it comes to completable futures. So in this case, when I cook tomatoes in the spice base, right? There is cook the base ingredients. We just created this. And since I'm doing all these operations in the end, I have a run does not return anything to me. So my completable future actually returns a void. And what I do with the void is, if it succeeded, I have nothing to capture. But as if there was a failure somewhere, I get a throwable. And this is how I use a void operation to overcome the lack of any outcome of my completable future. I can use a void v, ignore it completely, and look for what a throwable does. And that's when I basically call a handling to add tomatoes and curry powder and cook. I then have to do a then accept to cool the puree, which is another call to a consumer. And then I join to make sure that all of these operations execute, right? So basically a join or a get is the terminal operation. If you know streams, it is very similar to streams. You have basically intermediate operations, and you have a final terminal operation of a join or a get. And that's what completable futures require. Okay, so at the end of the day, you need to perform one of those operations to actually start the process. Otherwise, they're not going anywhere. And that's something I want you to keep in mind. All right, so that was making the masala. So let's go check that off. We're done with making the masala, and I'm going to mark this is done. Good. So now let's take a look at the two remaining things and a quick check on time. We're about 5 minutes left in the scheduled programming. Hopefully, I'll take another 10 minutes additional after that. So the cooking, let's take a quick look at the to-dos. What do I have? I have several to-dos, so let me speed this up a bit. I use an executor. There's a chop cilantro method. There's a roast or grilled paneer. This is interesting. This is what I want you to know. You can create delayed executors, right? Although you have executors, you can also create what's known as delayed executors. Delayed executor is something that can be delayed by a certain time unit. So here, the to-do says create a delayed executor. So in interest of time, I'm simply going to use my completable future dot delayed executor, and the delay time is for 20 seconds. So I'm going to put 20L, not 20L, 20, comma, and then it says use a time unit of 20 seconds. So I'm going to use a time unit of seconds, and I can delay, either create a default executor from a get-go, or I can create it based upon the current executor I have. You have both choices. And in our case, we need an executor based on our current because there is a race condition I want to avoid. I can either roast or grill paneer, okay? I don't want to do both. So I set up executors for both, and one of the executors I want to delay is the grilling. I assume I don't have skewers, so basically I want to delay this. So while I'm searching for skewers, the other part of the paneer tikka that I have already, I can put on an oven roast. So here I use a delayed executor that is delayed by 20 seconds, and the oven roast executes faster by 20 seconds. So now I have this race condition avoided, and how do I pick up either of these having completed is where I can use an any off method, and that's what we will do here. So instead of saying I need to do X action, I'm giving it two possible actions and saying when one of them completes, use it. And that's what an any off operation does for me. And let's take a quick look at that. And also it says that once it is done, accept the value and log it. Okay, I'm not just doing an any off, I'm also consuming its value. Okay, and its outcome should be a void completable future, which is what an accepting method does. It does not return anything, and that's what we want in the end. Okay, so let's do this and let's replace it with cooking any off method. So let's take a look at any off, and then we'll run that. So we see I have either grilling or oven roast. And obviously, since we've already decided to favor oven roast over grilling, this is delayed by 20 seconds. The oven roast should complete faster, and that's what I will be logging. So once again, just a quick check on the actual log output. And somewhere in here, you'll find that we have oven roasted our, it should show up somewhere. Preheating the oven, there you go, we oven roasted. Right, so that's what we did with the any off method. That was easy. And then there is the methods to basically add cream and cilantro, garnish. And in the garnish, basically, the question is, should I garnish with lemon juice? Some people love lemon juice. Some people absolutely hate it. Me personally, I don't like lemon juice in my paneer tikka, but there are people who absolutely love it. So the question is, lemon juice as a garnish. It depends on the mood. There's a positive and there's a negative. So here we create what is known as a Boolean completable future. And what we do is we do a random Boolean generation. So it's either true or false. And based on it being true or false, we either have a positive or negative message. So the positive message is basically where I have a completable future that is returning a true, which means I want it to set a positive message. In this case, I can do a Boolean dot complete. We've already seen the complete method before, but we saw it for strings. Here, I will be creating a Boolean that returns a true. And that is my return of a Boolean completable future, which returns positively. Now, in the negative case, while I have complete, I can also complete exceptionally. So I can throw an exception. That's what I want to show you. So a complete exceptionally clause is something quite interesting. And this basically creates an exception called no lemon juice garnish exception and says no to lemon juice. So let's take a look at how I create an exception myself. So for this, I'm going to again cheat and use a complete exceptionally clause. Here you see I created a complete exceptionally, and it throws a no lemon juice exception. So we've seen failed future, we've seen complete, completed future, and complete exceptionally. So this is my way to force complete a completable future. And this is my way to force complete exceptionally a completable future. So I have the power to cancel or do something similar in a completable future. All right, once I get these, once again, I'm in a situation I don't know whether it is a success or a failure. How do I handle it? In the past, we've seen a when complete, we've seen a handle, and now let's take a look at how we can chain into that chain that we originally saw where you can have different paths. So we will use an exceptionally method to basically chain our calls back. So very quickly, I'm going to just use my, I guess, friendly shortcuts to do this as an, I believe this is basically complete exceptionally. I don't know this one. What do? I basically do a then apply, take the Boolean value out of the whatever outcome was. If it was a success, I'm basically applying the positive message and I'm returning a null because I don't really need the value. But if I fail because it was a complete exceptionally, I warn saying use the exceptions root cause and get its message, which is nothing but a no lemon juice garnish exception. This is wrapped into a completion exception. So I have to, under the completion exception, go to the cause, which is my lemon garnish exception, get its message, and then return a false. So I could return a null too. It shouldn't really matter. But basically what I do is I am either able to handle a success or a failure as it happens within a stream, which is quite different from how handle or when complete work. Both of handle and when complete may terminally operate, while an exceptionally can be a part of a stream and can rejoin where I can simply do another then and it continues the path. So this allows me to go back to the path of success should I be able to successfully handle an exception. I want you to know that there are 3 ways of exception handling. Last but not the least, one of the methods that we saw was any off, and it's equivalent to ensure that everything completes is an all off. So I want completion of roasting. I want completion of chopping. I want to change this to a compose to heat after I'm done both of those and cook with cream and cilantro at the end of it. And then at the end, I just want to garnish, and this should either throw a positive or a negative message as an output. So let's quickly run this as another live template shortcut. So I use my all off method here. So I'm going to explain this. All off basically takes all my operations that return completable futures. And once I complete both of these successfully, not F1, but both of these successfully complete, then I compose async, which means I create a pipeline to heat and puree. And once I've heated and pureed, so that pipeline completes, I then compose adding a cream and cilantro and cook operation. And when that completes, I run. a garnish method. A run obviously does not produce anything. So the end outcome of an all off, this particular call is still a void. I wanted you to know that. So we've completed creation of the cooking aspect on the how-tos. So we're done with this. So what we are left with actually is to complete actually the real cooking. Everything we've done is create the recipe parts. We've not cooked anything. The log4j messages that I use are all configured here. Basically, this tells me where my log4j configuration is. And I want the thread context to be inheritable when I call it in different classes. So when I create it in my, let us say, one of the recipe parts, and then I call, let us say, my delay executor in the recipe part class, I want the thread context to be carried forward. And that's what I'm doing, right? I created an executor service. We already talked about this. Created an overall timer to start my Paneer Tikka masala. And at the end of this, I want to actually finish this timer and clock the amount of time it took. There's a logger. These are the recipe parts. We've seen this. So let's first check the ingredients. And this is how we do that. Then it says, go ahead and create the Paneer Tikka and then marinate. So there is two operations. There is the Paneer Tikka, and then I have to marinate it. If you, in case you forgot, in the Paneer Tikka, if I were to go to the structure view, there are two methods. There is a prepare Paneer Tikka and there's a marinate. And we left this hanging saying we'll fix this later. And this is where we need to fix it. So very quickly, since I am the chef, I'm going to use the chef method protocol to create a Paneer Tikka. Let's take a quick look at what I did. I call the make Paneer Tikka, prepare Paneer Tikka. And once this is done, the output of this is then composed into marinate tikkas. And if we go take a look at the marinate tikkas method real quick, you notice that I basically take this value and print out the remaining parts of the marination. And we'll take a look at that in our output in a little bit. So we created the marinated Paneer Tikka. We're good. We get an output from prepare Paneer Tikka that we don't use anywhere. So the S is meaningless, but that's okay. I want to show you that it's possible to ignore the value of what you get as an outcome. Then we want to prepare on masala. It's a simple uncomment of this. And the reason these are commented out is because if the changes we just coded were not made, all these would actually hang your program. So I had to actually comment these out. Now that we created the paneer and the masala, the tikka and the masala portions, we have to ensure that both completed. And the right operation to do that would be an all off. We want to ensure the completion of tikka as well as masala. And the outcome shows as complete when the second of the two completes. And that's what I want you to remember, right? Even in your output, you'll notice that they both print at exactly the same time, 8:34, saying marination is done, masala is done. That is because it probably was waiting on the masalas, on the marination to complete. The masala may have finished a long time before that, right? The masala finished at about 7:81, whereas the marination may have taken that longer time, which is why you see both of them show up at the same time in the logs. So that's what we do. How do we do this? So we go back and take a look at the to-do. It says use an all off. I'm going to use my chef again in interest of time. So I'm simply going to do chef, use all of tikka and masala. And it is as simple as an all off using paneer tikka and masala. And then I join. So this becomes a terminal operation. Unless I make the paneer tikka and masala, I cannot cook anything. So I have to wait for this to complete. And this is a terminal operation to wait for the make recipe parts to complete. I did that. And now I can log that this is complete and this is complete. And those are the two messages that you see at the same time. And now I have to join the cooking.cook. Remember, we still have a cooking part left to that, and we never used that. And the cook method was the main part of cooking. So let's go back to the structure, and you notice that cook is the method that we want to call, which did all of roasting, chopping, heating puree, etc. We still didn't call that. And that's where I'm going to uncomment this code and say, hey, now that I have everything completed, the parts completed, I can cook. Once I cook, I no longer need the terminal operation, so I can get rid of these. So I expand this again so you can see more of the screen. And I don't need to actually time out anymore because I actually have the join method which will complete, and my cooking.cook would never be reached if the all of paneer tikka and masala are not complete. So this is now meaningless, so I can actually get rid of this. These bits of code existed, so my program doesn't crash and burn if you simply launch it without making all the kata changes. So that's why I had all these extraneous, commented out sections, uncommented out sections. And then there's a final await termination for the executor. And this is always healthy code. When you create an executor yourself, you're basically allocating some threads. and you need to ensure that they close before you exit your system. Since I have a Java application, not a framework, I'm using a system.exit to actually exit out of my application. You normally should not be exiting. But in my case, what I do ensure is before I exit, I wait for about 200 milliseconds for all my threads that are currently running to complete, and then I exit. This is a hygienic strategy for using threads, especially if you use your own executors. So with that, I think we've completed all our parts. And if I run this, hopefully I don't embarrass myself, we should see an output. And lo and behold, we spent an hour 45 minutes creating Paneer Tikka Masala from Paneer Tikka Masala class, not from the solution. So that ends the portion that I wanted to share. And I'm going to go back on camera in a few minutes and take any questions that are remaining.
Chandra, I didn't see any questions on the chat, but oh my God, that was a fantastic session. You spoke for 1.5 hours on this topic nonstop, and that is just amazing. I just want to say that first.
Yeah,
Thank you.
it was a wonderful session, Chandra. We don't have any questions in the chat, but people, please feel free to unmute and ask any questions you might have.
Okay, so there were a few questions about the live templates and the I think there was something else asked. So I can share that portion if anyone is interested. And if you're not, it's feel free to drop off or ask me questions on Twitter or wherever else. Okay, great. So first things first. I guess the first question was, I'm sorry, I forget the first question. The live templates, right? So for the live templates, if I were to go, can you see my screen, Sinisha or not?
Yeah, we can still see it.
Yeah.
Okay.
Okay.
So the live templates are already present on your code if you were to check it out. If I open the project window, right, you have the IDE directory, and under the IDE directory, there's a ptm.zip file. This already has the live templates that we are looking at. Okay, it's not something that is sitting outside just in my code base that you can't access. The zip file exists, and the way you can import it is if you go to your on a Windows or a Mac, they're slightly different, but there is an import mechanism. Once you import settings, I think there's a file menu import in Windows, and its equivalent in Mac is under Manage IDE settings. If you import and you point to the ptm.zip file, which is under my projects, conference, Paneer Tikka Masala, IDE, ptm.zip, it basically will load all those live templates in for you. That is how you can use these live templates. Now, don't use them because I want you to actually code the kata yourself. But if you want to create your own presentations and you want to use live templates, here goes. So under IntelliJ, in case of a Mac, it's under preferences. I think it's settings in a Windows environment. You can actually go search for what is known as live templates. And you have live templates. And here are my live templates, right? In my live templates, what I do is I create a new group, template group, and I, let us say, call it demo. And this, I have Paneer Tikka Masala, but I'm just showing you a demo. So I create a demo. And once I create a demo, I can go add more live templates to it. And the live template I say is I want to do a system.out.println never use system.out.println because that is how Chandra remembers things. Okay, so I create this, and basically I can define a context where I want this. I can define it as a Java context. So anywhere in Java I use, it shows up, which is very generic, but you can also choose to trim it down and say only show it under a comment, only show it in a statement at a declaration level, etc. So for ease of use, I'm just going to set it to Java for now. Okay, you do that, and the next cool thing you should do is also hit the reformat according to style. So based upon where you are, it'll set the indentation and everything else for you. And let's call it bad CVG. Okay, for lack of a better word, Chandra is being bad. Okay, notice what I did: bad CVG, Chandra is being bad, and the text. Okay, remember these things, because when I hit apply and OK, and I go back to my code over here, let's say anywhere in my code, right here maybe, and I now type bad, it actually shows me bad CVG and Chandra is being bad. And when I click this or I tab, it'll complete and it'll actually show that line right there. And that's what live templates does for you. Okay, it's not rocket science. It's basically shortcuts to code that you frequently write. And especially if you are demoing a code kata. This is a very handy tool, so you don't watch me make typo errors and waste your time. I would much rather spend my time showing you what I want to show you. Okay, so that was one. I also, if you were noticing my agenda, I was able to change these because I have a live template for that too. And the live template is basically going against emoji characters that you can use in your IDE. Most modern IDEs support emoji characters. In a Mac, you basically do this and you get all your emoji characters right there. So it depends on where you are. You can actually set up emoji characters. I set mine as done being a live template that prints out a checkbox. It's as simple as that. There's no magic there. The last thing that I wanted to cover that someone may be interested in is the log4j XML file. It's probably located under the main resources. Here is the log4j XML file. And basically what it does is it creates a few appenders, right? Appenders are basically how you print out on different devices, console or otherwise. And I create a top level. This is what the Paneer Tikka Masala main method uses. And each of the recipe parts has their own, where I have different, I guess, icons and different things that I print out, right? And each of these basically prints what is known as the recipe part, which is where your thread context came in. And somewhere down below, my thread context is evaluated, maybe around here. It uses conditional checks to determine which of the thread contexts I'm specifying. Each one of them has a thread context called recipe part, and that's what I print for each of them. And that's it. That was what your output was showing in the log4j. So there's no rocket science. It's just a matter of something I find very interesting and cool, and I set it up. It's geeky, if anything else. All right, cool. So I showed you what I wanted to. If there are any further questions, please feel free to let me know.
You are good, Chandra. I don't know if you can see the chat. Lots of people are.
I'm now able to look at the chat, yes.
Okay, good, good.
All right, very cool. In case there are no further questions, I thank you for your time, and I apologize for encroaching about 14 minutes over, but thank you so much.
No problem.
Thank you. Thanks a lot, Chandra.
I appreciate it. But yeah, thanks for coming, everyone. Like Surisha shared early, we have sessions coming up in April and May, so hopefully we'll see a lot of you back then.
Yeah, and those are amazing sessions. Both Matthew Gillard and Prateek Patel are amazing speakers, so please don't miss those sessions.
Yeah. Thank you for that additional nudge, Chandra. Yeah. and hopefully some of you can also follow us on Twitter, because we're quite active there as well, and we're posting, and we're also sharing a lot of Java resources and other Jug events that are happening around the world, and we've been sharing those as well. So those might be something that you might be interested in attending. So follow us on Twitter. I don't know if we have that handle up again.
But yeah. Thanks, everyone.
Thank you.
Good
Thank you,
evening.
everyone.
Thank you.